Right, hello up there in the bright lights. Yeah, hi. This is a very big room and a very big screen, so hopefully it will all work well. Yeah. I don't have any code demos today, not really, so everything should be pretty swimming, really. This will be one of the most boring talks I've ever done. So sorry in advance, I'll try and keep it light. I work for a company called Ideas, and my name's Rob Ashton. I've been to a pile of these it's called DevConf now, isn't it? But Dev Day back in the day. So I know a few faces in the audience. Forgot most of them as well, thanks to vodka. So yeah, I work for Ideas, and that is indeed a company. We build bespoke media workflows. That's very exciting. They look like that. Yeah, this means nothing. You just show it to clients and go, yeah, that's how these things work. But essentially, we build a pile of stuff which takes video in one end and spits it out the other end. That's what we do. Terribly exciting. The hard part of all this is generally around orchestration. A lot of the work we do is on demand, so events take place and coders need allocating somewhere, either in an internal cloud, private cloud, or somewhere on Amazon or presumably Azure, but no one uses that, so thank God. Networking's dreadful in Azure, let's face it. So we do that stuff. We've got some fairly cool UIs for doing like live web editing of videos as they go out, and they're pretty neat. We do some commentary via WebRTC, so commentators at home in their underwear can watch a horse racing thing in the web browser and do live commentary on that, and we'll automatically sync up the video and audio so it just works. That's pretty sexy. Obviously, there's other audio contributions and things like that too. And the combinations of all these things are large. They're all the same, but they're all slightly different, like every single one of our customers. So they're all little snowflakes. So we're doing hundreds of thousands of events a year, and that's pretty neat. This photo's out of date, but we've had 2 new people, but I've not met them yet, so they don't exist yet. That's how that works. So this is the programming team. There's 2 people missing from this photo. As you can see, we're quite a small team. We have more clients than we have software developers. This is the ops team. So these are the chaps that look after everything running in production. And this is the support team. So when the clients have a problem, these are the chaps they get in touch with. So as you can see, there's some conflict going on here, because in order to carry on building new stuff and get paid by our clients, we kind of have to go forwards without really supporting that old stuff. Now, the customers obviously pay us for support, but we don't want to give it to them because that costs us time and money. So ideally, we just want that revenue coming in and our effort to be spent doing other stuff, which we get paid even more money for. So to do this, we need to write software that is self-supporting as much as possible. Now, I have another colleague in the room with me, so he'll call me out on this. I'm only talking about the software I work on. Now, the stuff he works on is dreadful, so he does lots of support. But the stuff I work on, no support at all. So there's one of our clients, they're based in the south of England, and they've had their channels and things sat there doing work the past 3 or 4 years. We've not heard from them. They're paying us for support, and we've literally not spoken to them at all. They got in touch about a month ago, and of course, we were like, oh no, what now? And they were asking for more features, more functionality, like 4 years later down the road. So it's been happily ticking away on their site, and we've done nothing to make that happen. So that's pretty neat. And certainly that's the aim when onboarding new customers, is to keep that. So the format of this talk is very much how we approach building software that gets into this kind of state. And this may not be applicable to what you work on. These are certainly not going to be a set of rules to follow. There are no rules in this slide deck. And if anything looks like it's a rule, please don't take it as being one. This is what works for us with the kind of software that we build. So with that, let's jump into the first thing, our approach to code. Does anyone here know Erlang? Yeah, Tumbleweed just drifts through. There's a few hands in that audience. That's good. So we actually write everything in Erlang and Elm. And I will show some code on the screen. Don't worry about understanding it. It's not going to be important. But our approach to code is to write code to effectively be thrown away. So you don't tend to write lots of interdependent modules that have to rely on other pieces of code. Generally, things need to be self-contained so you can delete them. Because that's our favorite thing to do, is delete code, obviously. We want to try and reuse as much as possible, because every time we're going and onboarding new clients, we don't want to be reinventing the wheel when building these bespoke media workflows. In general, don't use third-party code. It all sucks. And that's a contentious one, I know. But in general, people don't know their ass from their elbows and can't write Erlang. And that's fine. There's a few good core libraries that we have grown to trust and like over the years. But generally, you don't go and search a repo and just pull down modules like you would, say, in Node.js land, where you go npm install something to add two numbers together. We avoid that at all costs, because all third-party code is generally rubbish. Except, of course, that when third-party code is better. So every now and then we do find a piece of work by someone else on the internet who knows what they're doing, and we'll bring that in. But we'll own it. We'll take, these are source dependencies. The source comes into our projects. You actually look at the source and go, what's it doing and how does that work? Because when there's a problem with it, you don't want to be going on GitHub and asking for support of some chap who's probably also overworked on some other project they're on. So in general, when we pull down third-party code and there's a bug in that third-party code, we fix the bug in that third-party code and submit a pull request. We do end up with forks of quite a lot of major projects. For a while, we were running our own fork of libav. That's like 3 or 4 years of that. Obviously, we don't reuse everything, so that first thing is a little bit of a misnomer. All the core stuff is completely reused, though. In terms of code quality, well, for a starter, for the last few years, we've written every one of our UIs in Elm. Has anyone here used Elm yet? Who is sniggering in that down the front there? Yeah. No, Elm is a beautifully strongly typed language with very few bells and whistles, and gives a very enforced way of writing code. And that does mean we never get UI errors. And that's neat, because we all hate doing UI work. Absolutely despise it with a passion. And we have a lot of UIs, but we'll talk about them later. Generally, again, this is how I do it. Steers is going to look at me funnily in a second. When I write Erlang, it looks like this to begin with. Now, that container over there is your equivalent of a class, let's call it that. You'll see there's no type information on that whatsoever. There's some functions that take in the container and add the two values together and turn a new container. Okay, great. Very simple example here. Generally, when I first write code, it looks a lot like this. It's very bare bones. There's no type information, and it's rubbish. As I go through, I might add tests to this code. If this code lasts longer than a few days, it might be lucky enough to have tests bestowed upon it. In general, I write code the first time. It's normally horrendously wrong because I misunderstood what the customer actually wanted in the first place. So you go away and rewrite it again. And I might add some tests that time around to make sure that the functionality is roughly right. And the third pass, when this code starts becoming core, when it starts being reused by other stuff, you start typing actual type annotations to absolutely everything. And you can say, well, actually, that value's always been integer. There's some documentation here telling you what this function does. There's some type information so you know what things are being exposed. And you can selectively start adding this stuff. I quite like that way of working. I like being able to just throw things at a wall to see how they stick, but obviously, in the JavaScript world, you've got TypeScript. You can write things first in JavaScript and then probably throw that away and write in TypeScript. You probably can do that. I don't think many people do, but you can do that. Clojure has the same kind of thing going on. And being able to gradually mature your code along with your code base is quite a nice way of working. Because you have to accept that nearly all code will get thrown away to begin with. So first time round, the quality is not important. What you're actually trying to do is just spike the functionality and say, hey, is this actually what we needed to do? Is this the way a system needs to work? And generally the answer is no. You're never going to write first time. I think nearly all of our serious heavy-duty core libraries are on a third iteration now, and only now are they really not being touched anymore. And they're normally drastically different when they've been changed as well. So there's no point writing tests for the first time round because those tests are completely invalid. So system design, let's move on to that. How do we approach that? That's good. Identify our absolute truths. That's a pretty heavy slide, isn't it? Identify our absolute truths. It's we're going to use this photo as a representation of absolute truth for the rest of my slide deck. So absolute truth is normally external data that the client owns. So, or controls, shall we say. They might give this to us by calling an API in our system. We might get it from them by calling one of their APIs. It might just come from someone opening up a web page that we've given them and putting data into a form. We don't own this data that they've given us. This is their data. This is their representation of what they want our system to do. And examples of this data... So the idea is from this truth, you can always rebuild all our state, and we'll get to that. So examples of this kind of data would be in a static media workflow system, channels. You know, a TV channel has somewhere where it's going to get some data, and it's going to have some outputs, places it's going to send some data. It's going to need to know what different encodes need to be generated and where and how that's all going to work. And they're going to enter that into our system. At that point, they've given it to us, and that data should remain completely sacrosanct. You never write over it, you never modify it, you never adjust it. And it's all too common when we build systems that we start throwing things in a database and update things willy-nilly. You've got someone entering things from a form, and then something running over here as a long-term running process will come back and modify those tables as well. And then generally, it's not a good way to build a system because its state is obviously the cause of nearly all bugs. So obviously, events are a source of truth as well. This event starts here. It's Beach Volleyball episode 2000. That's my favorite source, by the way, to test on when I'm on the client systems. The events start and they stop, and going to get them over here, and outputs are going to go over here. Great. You've given that to me. I'm not going to change it. Because from this data they've given us, and they might choose to modify it at some point in the future, we can identify jobs that need to run in our system. We can identify tasks and generate secondary sources of truth if we need be. But the point is we can generate all of this from the absolute truth at any point. And we'll get back to why this is really useful later on in the slide deck. I'll come back to it. If I don't come back to it, holler at the end and say, Rob, why is that important? Jobs are generally written to be self-contained, single purpose. Generally, failure as a unit is isolated to a job, and jobs are normally blind and autonomous. They don't need to read from that single source of truth once they've been told what they're doing. Everything is copied and isolated, so things can run by themselves and go off and do stuff. An example of a job would be, for example, if I spin up a channel in one of my client systems, I will need to go from that channel and say, well, I need something to package the outputs from that channel. I'm going to create a packager and deploy that somewhere. I need an encoder to run somewhere, or two encoders to run, because it has a lot of work going for it. I need to configure those encoders. So I'll generate the config for those encoders and store that somewhere else, so I can then send that on. Again, never writing back to that source of truth the client gave me, because that is sacrosanct. The process looks like this in nearly every single piece of code we write. You've got source of truth coming in the top. There'll be some kind of controller taking that source of truth and creating jobs from that, creating more data, creating copies or transformed versions of that data in order to run jobs. It's just a transformation process. But you'll see here that the communication is pretty much one way. You know, you've got a source of truth saying, this is how the world should be. You've got a controller going, great, these are the jobs that need to exist. You, over there, exist, do your thing. They're independent, so if one of these jobs goes away, the other jobs carry on working. That's what I meant by that. If they're autonomous, if the controller goes away, jobs hang around and carry on doing their job. That's important because things do fall over and break. Data flow looks a bit like this, again, in nearly all of our systems. This is all back-end stuff. Absolute truth comes in the top, gets transformed by a controller, and you create a pile of config for jobs running down the bottom. So that's cool. Oh, cool. I made little numbers and things in my slide deck. I must have been feeling fancy when I put this together. That's cool. So yeah, controller receives absolute truth, tests the current situation, generates jobs in config, and the controller pushes config to those jobs. Great stuff. The controller can pull those jobs for status if it needs to and say, what's actually going on? What are you doing? What's happening down there? For example, you might ask an encoder, what's your current input? What's the resolution of that input? Are you interlaced? How many audio streams do you have? Because we can then store that somewhere else in our database as yet more data, again, never modifying the original data, and use that to generate more UIs or further config down the line. And obviously, just repeat this in a loop. So generally, the controller might respond to status by writing more truth somewhere else and generating more jobs. And that's entirely reasonable. And the thing is, truth changes, especially in this modern political climate. You've got this absolute truth at the top, and suddenly you get a new absolute truth. The client comes along and changes it. You can just run this loop over and over again and say, hey, that changed. The controller can say, that's not how the world looks. I'm going to make the world look like that. If they change it again, the controller can say, hey, that's not how the world's supposed to look. I'm going to change the world. But again, always going one way and always hammering that truth down in a one-way stack, constantly saying, this is what the world needs to look like. You've got the client saying, this is what the world needs to look like. You've got the controller saying, this is what the world needs to look like based on that information, and so on and so forth. But it's just a pattern. And it scales up into a hierarchy very tidily. You can have jobs generating their own data from the truth that they're given, and they can then generate more jobs. But again, never overwriting the state they've been given, because data flow is one way. Very important. Now, obviously, this looks like something else. It looks like Elm Architecture. Our front ends work in the same way. You've got a model, and you've got an update, and you've got a view, and changes to the model incur a re-rendering of the view. You've taken an absolute truth, and you're generating more data from that. If you use React.js, that's fairly cool these days still, isn't it? Is it not cool anymore? I can't keep up in JavaScript world. I'm sure everything's doing it now anyway. The whole virtual DOM thing became a bit of a fad, didn't it? So React.js works this way too. You've got state and you've got props. From the state, you generate props, which then generate more components, which can then do the same thing in a hierarchy. Turns out this is an incredibly effective way of writing systems, both front-end and back-end, recognizing that there is state that you are given and you should not modify. Everything is read-only. This is what it looks like in Elm world. You've got a model, messages come into an update function to modify that model, and as a result of that model changing, you call a view function, and you get a pile of HTML out. Whoop-de-doo, very exciting. It's not too important. So all of this is really, really great, and on a good day, our systems would work brilliantly, because that's all you need to do. You just need to generate jobs from config, and off you go. The problem is infrastructure never works. I think today one of our clients is running a virus scanner on their encoders, so things weren't working, surprisingly. Every now and then the firewall team decides to fix their config, and it generally means things stop being able to talk to each other. And you have to be able to roll with that as much as you can. You have to be able to carry on rolling forward. And obviously job autonomy helps a little bit with that. This is... It's the White House, it's very apt. Right, so in reality, you do get net splits, either in the cloud or even on local systems. If you've got these high-density units we use to build private clouds with, things do happen. They can't talk to each other sometimes. What are you going to do? DNS fails more commonly than you'd like. You do get bugs in our code. Jobs do crash because they get some data you don't expect, and they just fall over in a heap. Disks do fail. Disks really do fail. Disks fail a lot. cheap SSDs in these high-density units are absolutely appalling. And obviously, the most common failure is human error. Normally, someone goes and presses the wrong button. That's normally the common one. Normally, it's me pressing the wrong button, to be fair. So that's fine. So inside an Erlang application, all of this stuff I'm talking about actually are automatic. You have these concepts known as supervisors and workers, or supervisors and gen servers, and you can set them up. I got a picture. So the controller can say, hey, create this job over here. And if that job crashes, the supervisor's job is to go, hey, that process crashed. I'm going to start it up again with the config it's meant to have. So you can deal with crashes by just letting things fall over in a heap, because the supervision structure will constantly keep trying to make the jobs that need to run carry on running. This is an automatic thing within an Erlang application. You build everything this way. This is an example of one, which thankfully is big enough on this screen so you can see what's going on. This is Erlang. It's pretty, isn't it? So what's going on here? I can't actually point. I'm not a laser pointer or anything like that. When the supervisor gets started, it decides based on some config it was given just here whether to start up this child or this child. This is a very trivial example of a supervisor, but it's a nice, apt one to describe. So you've got two children here who haven't got any config. They're just doing something really boring and getting told to get on with it. But based on some config we've got, we might start up a different tree over here. If this whole supervisor crashes, its parent supervisor will restart this supervisor with the config that it had, and it'll restart all its children automatically. And that's quite nice. Similarly, if any of these children crash, it'll try, I think it's 10 times within 10 seconds, I think that's what that means, to restart those processes with their config again. Because things don't work. You try writing to the disk, and some idiot didn't delete files, and it's full. So something crashes until you delete the files on the disk. You try and write something on the disk, and someone's changed permissions, and that doesn't work either. Or there's just too many file handles open. I don't know. All sorts of things can go wrong. The point is you haven't got to try and handle those things explicitly, because they're just daft things that happen. So you can just roll forward, let things crash, and let Erlang's supervision structure sort things out for you, which is nice. You can kind of do it at a macro level across a cluster as well, but you don't do that because of some limitations in Erlang itself. So instead, you manually do monitoring to bring up this thing side. So what I mentioned earlier, controllers can pull status information from their jobs. Well, it might do that. And part of the status information might be the global PID of that process. Now, a PID is just a way in Erlang to identify a process running somewhere within a cluster. But the controller can say, cool, give me your status. That's your PID. That's nice. I'm going to monitor that explicitly. I'm going to add a monitor to that PID. If that job goes away, you instantly get notified. And that might be because the network drops, or might be because the job crashes, or could be anything like that at all. But the controller can get notified within 1 second. That's the net tick time thing down over here, that's happened. Obviously, you adjust net tick time based on the environment you're in. Locally, it's 1. And our private cloud infrastructure tends to be like 10 seconds or so. And in the actual cloud, I've got no idea what we're using for that, because I very rarely touch the systems these days. Yes. So yeah, create the new job. Wonderful, happy days. This can actually be automatic, but there's a limit in Erlang to how many nodes can exist in a cluster without being hidden. So you need to actually work around that. Obviously, zombies are a big problem still in this environment. Now, with these supervision trees, they're not a problem. If you build these things correct, they're on zombies. Erlang will always kill all the children. It'll just dispose them all. Bye-bye children. Happy days. And it'll kill their children too, and their children and their children. So nothing will... file handles of processes, they get cleared up too. Everything gets cleared up automatically. Very tidy, very nice. In a distributed system, it's not quite so fancy. So a common scenario is, again, you've got source of truth up there. You've got some jobs being ran. And some doofus pulls a network cable out. Or there's a net split, or who knows what happens here. Firewalls get changed, whatever. The point is, it can't talk to the controller anymore, but it's still doing its job because it's autonomous. It's happily doing that. But then someone comes along and modifies the truth. So the customer enters a web UI and goes, yeah, that event's over, or that channel doesn't need to exist. And that job's still running. And the controller goes, cool, I'm just going to forget all about that job because it doesn't exist anymore. And that split goes away. And that job's just sat there ticking away autonomously on the node somewhere. You can't allow that to happen. So the job actually needs to keep a track of whether it needs to be alive or not. And there's a handshake between jobs and controllers to allow this to happen. And again, every single level of our software stack, whether it's in the cloud environment or even inside Gen servers. So the job can say, am I meant to exist? And the controller goes, who the hell are you? Like, what are you doing there? The job can go, oh, I'm dreadfully sorry, mate, and get rid of itself. Jolly good. This happens an awful lot in our actual environments, mainly because people just restart stuff willy-nilly, so you've got to keep dealing with it. The point is, keep alive on absolutely everything, because nothing will work and everything will break. And this goes for state as well. I'm not sure I've got that in here. Have I got that somewhere? Oh, we'll see. I might come back to that. Right, development, that's an important topic, isn't it? Because, in order to make all this stuff work, we have to build it to begin with, right? Working on all of this locally. Well, my rule is emulate absolutely everything, so I can work locally. We all work remote. There is no office. There's nowhere to actually be. And most of my colleagues work at home or in a co-working space. I am probably the exception to that. I just work anywhere that I feel like. I rove around. I can often be found in wine bars and pubs and such, and they haven't got the best Wi-Fi, so I can't rely on the internet being there. So I need everything to be local. For an example, this is, it's a Contron, isn't it? That's a Contron. That's a high-density 2U server with 18 CPUs on it. It's cool, isn't it? It's actually really sexy. My favorite piece of equipment. I haven't got one of these in my house. A, because I can't afford the Alecki bill. B, I can't afford one of those anyway. And C, I actually like to have like a cool environment in the house, and these things run really hot. So I need to pretend I have one at my house. So to do that, I've got a Rundosher. That's cool. I'm going to go and run my Rundosher. That's, I'm not sure who that is, actually. Is that Princess Luna? That's Luna. That's good, yeah. If a pony's desktop, you just forget who they are, don't you? Right, so look at this. I'm running a script called Rundosher, and it's spinning up a fake cluster. It's spinning up a fake version of Akamai. Have you ever heard of Akamai before, the big CDN? Unfortunately, we have to talk to that quite a lot. We deal with CDNs quite a lot. They don't work very well. So I've got a local version of that so I can test things properly. That's spun up. I've been working on some stuff and I've broken the entire system. That's fantastic. We'll ignore that. I was just sat there on chairs doing work just now, and I've crashed the system. But it's not important for this demo. For this purpose, on my system, for this local one, I do it all with Docker. So I create a fake Contron with 5 nodes. I run an etcd cluster on those 5 nodes. And they've all got the same software they would in a real hardware environment installed on them. They're effectively virtual machines. The only reason I don't use VirtualBox or such is I like my RAM. I actually think that this is quite a lightweight way of doing things, but obviously you could equally use virtual machines for this locally. The point is, with one single bash script, any of the developers can spin up an entire representation of this system locally on their laptop, and it will just work, which means they can get right on to developing software, which is nice. There's no dependencies on anything in the cloud. There's no dependencies on any hardware. Everything is emulated. And that's super important. I can't go next. Exactly. So by mirroring your production environments locally, you get fewer surprises when you actually deploy, even to dev env. And I cannot stress that enough. I test everything locally. If I make a change to how orchestration works or timeouts work, I make sure that works locally, either by testing or running this whole thing up and running. It gives you faster iteration because you haven't got to ever deploy to any kind of environment to test your software, which is quite nice. And it's easy for other team members just to jump in there. I mean, the first time one of my colleagues pulled down one of these projects and it just worked on their laptop, they were like, whoa, why doesn't everything work this way? Now, of course, everything is now working that way, which is quite nice, mostly. Testing, there's a dirty word, isn't there? Unit testing, that's quite cool. I've already covered that. We core technology only. Write some itty-bitty tests, make sure it does what you want it to do. Great stuff. Talk about it less than I need to, really. For example, a core bit of software we have is something called the auctioning process. In the cloud, you can request spot instances from Amazon, and they're different prices and different regions. And based on different events that might take place and where those events are taking place in the world, you might have a priority for one thing somewhere or another. Things might be more urgent, other things. You need to try and maybe do some stealing of resources. The logic around auctioning is phenomenally complicated. So there's a lot of tests around it, a lot of tests, because I want to know that works. Well, that's great. Wonderful stuff. Integration testing, as far as I'm concerned, is a meh thing. Testing interaction between like two components is just dull. Very rarely adds much value on top of just doing unit tests, so don't really do it. This is more interesting. Running the whole system as a big unit and just pulling things out to see what happens. And that's what we'll do. So this is something that I run in one of our clients' dev environments every time I'm about to deploy to production. So the weekend before I deploy to production, I sit there and go, I'm going to run this and see what happens. I spin up a real system with a real number of channels, a real number of events, actual things happening on it, some serious orchestration going on. And then I start restarting nodes, deleting things, creating things, and in generally trying to break absolutely everything in as many ways as possible. And I just leave that running on a loop over the weekend. Just leave it running. I come back after the weekend, I turn off the Chaos Monkey, and watch as a system recovers itself. Because it's constantly running in that loop. It's constantly beating that state down. It's constantly trying to make sure things are actually valid. So the goal is I get back after the weekend and everything's fine. Now, because I'm a nice person, I will actually log in from whatever pub I'm in over that weekend and check that it isn't actually like falling over in a big heap, because I'm nice like that. But generally, I'll release to production if the Chaos Monkey runs all weekends and there are no zombies, no crashes, no failed jobs, and quitting that Chaos Monkey means everything comes back to life. It means I can trust it. When I say to that client, that's good to go, I've got a reasonable surety that it is indeed good to go. And I need to have that because I don't want to be doing support at 2 in the morning. I just don't want to. So the TLDR of all of that was testing core assets is absolutely a must, detailed as you need to be. End-to-end testing of the whole system and how it interacts together is absolutely a must. Like, if you can't automate that, then you've got problems because you're not going to be able to do that manually by clicking buttons. I'm sure some companies still have big written out scripts for long form testing or whatever that the testing departments go and run. We haven't got a testing department. We haven't got a QA department. We are the QA department. So it needs to be automated because I haven't got time to sit there and click every single button to see what happens. But anything in between these two extremes doesn't add much value, so you kind of ignore them. Yeah, great stuff. Monitoring, that's quite interesting. Yes, these are big systems. Not huge, but they're big. They're quite big. So for example of one of the clients I'm currently working with right now, across the 3 environments, we've got probably 500 CPUs running. It's not many. That's going to beef up quite a lot over the next few months, as they start onboarding more events and channels. But that's still quite a big number. When you're actually running all these jobs, if you're running encoders and packagers and commentary sessions and such, you are talking thousands of jobs just running away on the system. And they're all moving. They're all doing stuff. They're all communicating. They're all flowing data around the place. As much as I can avoid that, I do. But they still need to report back so state can be flowed somewhere else. Lots of things can go wrong. For example, you're running an encoder and the UDP source stops, or the input to that encoder is just plain wrong, or you don't recognize it because it's a codec that no one told you need to support. And that happens nearly all the time in dev environments. You need to know about them as soon as they happen. You just surface them. And the darling children for all of this stuff tends to be the same things each time, basically InfluxDB and Grafana are what everyone's currently using. And everyone makes really pretty graphs and charts that look like this. Who's got one of these at their company? Big, shiny charts and things. Who ever looks at it to actually do anything useful? You don't. This is what's known as a vanity dashboard. It's just to make yourself feel good. You have a shiny dashboard you look at and go, look at our shiny dashboard. Isn't it great? And there's no meaning in there at all. I can't see what's actually going on in my system. There's no alerts. It's just a dashboard. They have one purpose and one purpose only, and that's to sell software to clients. So we use InfluxDB, and we have used it for years now. Every now and then we pull it out and use it as entirely as a sales tool. We go, yeah, we've got monitoring. Look at this shiny. And they go, ooh, that's really nice, not knowing they're never actually going to use it. So the thing is, no one looks at them. They're great sales tools, and everyone loves them, but they're not actually good for anything useful. So all jobs in one of the systems can post things to localhost/flags, and they'll get redirected to something somewhere that will store something. In this case here, there's a packager, 1337, saying, I got a discontinuity on this source over here. Is that meant to happen? And there's something sat on their endpoint collecting all these flags with timeouts and such, and aggregating them. So we can generate prompts in the UI, for example. Here's a channel which has no traffic on its current source. And we go, cool, that channel has no input. That's why it's not currently working. And that's prominent in the actual UI they've got. You can aggregate them and say, look, this is the current state of the entire system. And say, hey, this is business-centric. Each of these things is a job. These are events, these are channels, these are encoders, they're packages, they're whatever they are. The grey ones haven't been allocated yet. The orange ones, something's gone wrong with them. And the green ones are A-OK. And you can click on these, and it'll take you to the actual resource involved, and you can go and look at what the error actually is and go and fix it somehow. We have introspection of our core workflows. This is a workflow that I think merges two audio streams, one from commentary, one from something over there, who cares? Each of these things has metrics in them. How many frames have I seen? How many bytes of data have I received? What's the bit rate of this source? What's the audio levels right here? What are my queue lengths currently? And these can actually change color if there's a problem. If a queue length gets too big, they'll turn yellow. You can look at them and say, that's where the problem is. Our clients can see these too, which is really, really useful, because they can go in and say, there's no source going into that audio. I'll make sure I'm routing it. This detailed introspection is really, really useful. It has the ability to drill down into the system without needing to actually open any kind of code or console or whatever. It's nice. So the point is, all we're doing here is highlighting the problems in the system, because everything else truly is noise. We have logs. We have lots of logs. Those logs get written. If something does go wrong and requires intervention, I can go and read the logs and tell you what happened and how we got there. But it's useless firing any of that into any kind of system that the client's going to see, because they don't know what any of it means. All they want to see is traffic lights, and they want to know what the problem is and how to fix it as soon as they can. Now, speaking of that, let's talk about our approach to disaster. So, things still go wrong despite all of our best efforts. Jobs fail to get allocated for some reason. Jobs end up with bad state because they crash. Basically, state there's always bad state somewhere. Something's wrong, something's horrible, state is awful. Now, we want to avoid this. We don't want to call us. We don't want them to give us a call. There are two reasons for this. One, I'm actually busy writing code for other clients. I don't want to be supporting those clients. Two, one of the stacks I work on is actually it's in the gambling industry. And one of the biggest users of the gambling stuff tend to be in Arabic countries who don't have holidays when I have holiday. And I don't want someone calling me on Christmas Day because I'm trying to eat turkey dinner or something, saying, this isn't working. I do not want to be responsible for any of that support at all, right? Don't want to do it at all. So we employ this pattern here. It's called the fix-it-yourself pattern. We give the customer buttons, lots of buttons. And all the buttons do is just kill stuff. The same way the Chaos Monkey does. The same way we would if we went to the system to do stuff. And because the system's constantly running in a loop, evaluating what the actual state of the world is versus what the source of truth says it needs to be, it will then go and reallocate systems that need to be reallocated. So because we have the ability to cleanly fix the system from any kind of failure, if one of these things ends up with bad state for some unknown reason, it's very easy for them to go, well, we'll just kill that, and it'll get reallocated in 2 seconds, and no one's going to notice. And that's super nice. So I give them that. I give them that power and say, these are the buttons. Go nuts. This is the order you click them in. Start at the lowest level, and if it gets really, really bad, restart the node. And everything will sort itself out. And it does, which is nice. So we can do this because the absolute source of truth never gets modified. It's always one way, which means it's nearly always correct, unless they give us bad data to begin with, and that's not our fault, so that's great. Most likely it's our local state that's broken. If you delete that local state and recreate it, you'll roll forwards in the world. Everything is fine and great. That's good. There's also, if everything goes really, really, really wrong, they have a script, and it just deletes every single bit of state we have in the system and restarts the whole system from scratch based on their absolute truth. And everything gets reallocated within about half a minute. Now, in production, you'd hope that never gets used. But again, they will try that before they call me. And that's what's important. I do not want them calling me. I hate support. I'm sure you all feel the same way. Well, I haven't got to do any. So, hey, I'm doing all right. Now, I can just go on about this stuff. I can pull code out and do all sorts of crazy stuff. But there's not much point, really. I actually got 8 minutes left, which is nice. Normally, at this point, I get asked questions about why not use other stuff to manage these clusters and such. And the main reasons even, are twofold. One, these are actually all nascent technologies. They're not mature yet. They're just not. Everyone's currently finding out how to do orchestration as a package that they can actually consume and use. And we're still working on it as an industry. Most of the tools out there are for static allocation rather than dynamic, so we can't use them really, apart from actual infrastructure we deploy to the cloud that remains constantly deployed. And all of this allocation, all of this state management and such, is core business. And you don't ship core business to other people's software. Because then you can't adjust it if you need to. So you avoid that at all costs. So because this is core business, because we are in the business of orchestrating these media workflows, we write that code to work the way we need it to work. And that works for us very well. And maybe in 5 years, 10 years, when everything's settled down, it'll turn out that whatever replaces Terraform, because something will be dynamic in some way, and it'll be mature, and we can probably go, cool, we're going to use that for all our allocation needs and orchestration needs now, top notch, but right now we can't do any of that, so we don't. And that's why I answered that question. Cool. Speaking of questions, has anyone got any they want to ask from the audience? Or are you going to do that thing where you wait to the end and come and see me? Yeah. Yeah. Shout really loudly. He picked the wrong project. So the question was, what's my colleague doing wrong, which means he gets support calls? The answer simply is he's working on a legacy stack, which is probably coming up on 10 years now as one of our first customers. And when I joined the company, it was impossible to even run that locally. You had to be sat there connected to Amazon to make anything work at all. I'm sure it's still halfway towards being that bad now. As a result of that, because it's not following this way of working, it does fall to pieces every now and then. Now, slowly, that stack is being subsumed by all of this code, and those problems will go away. I think in production they don't have many issues, do they? It's nearly always in staging environments and such, to be fair. All I know is I go on Skype, and I'm constantly seeing them asking, hey, Steers, what's going on? This encoder hasn't got any audio. And I'm going, hee 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 hee. Not my problem. I'm not the nicest colleague in the world. Any other questions? Yeah. Oh, there's a microphone. That's cool.
Thank you. So what are the preconditions if I want to use such a system, for example? Can this be applied to any system? Or
if you want to build a system using this kind of way of thinking, All right. So the question is, what's the preconditions? If I want to build a system like this, I don't think there are any. I think that the core tenets of what I'm saying with regards to state being generally immutable, that holds true in nearly every single system. It doesn't matter whether you're working on a CRM or whatever. Generally, writing back to state you've been given by a client is a bad idea. One-way data flow is nearly always a sensible idea in nearly any system because it keeps the logic more simple. And that's why all the UI frameworks have gone down that way. If you all remember the joys of using things like Knockout.js, where you had like two-way data binding on controls, and when you actually like scaled that up to a real application, there's just like fucking data flying left, right, and center, and you're not really sure what triggered what where. It's an horrendous way of working. I think some people still do that, but they're very much in the wrong. It's actually really bad. No one uses Knockout.js anymore, do they? Yeah, exactly. So, you want to say something over there? Are we having think also, God, WPF worked this way, didn't it? You tried doing everything with MVCC and, is it MVC? What's it called? MVVM, sorry, yeah. MVC is a multi-version concurrency control, which is something completely different. Yeah, so data binding in that context, again, you got two-way data flow, and it just ended up with, unless you were very careful, logic just spilling out all over your whole model. It was really quite unpleasant. So I think that holds true as well. Obviously, some of what I'm saying is unique to a system where you require orchestration. And most systems we deploy don't do that. If you're working on an enterprise application of some sort, most likely you deploy once to some set of infrastructure and every now and then do a redeploy over that infrastructure. If you're really sensible, you've used Terraform or something similar to manage what that actually looks like in your deployment environment. And that's fine, that's really good. But it's largely static. You're not trying to manage jobs in that environment. But if you're going down the microservice route, and these things are going to be on demand, then you have to think very carefully about where your state is and who owns it. And this is a good way of working. Erlang makes it all much easier, obviously. I don't think I would enjoy writing this in, most languages, really. I mean, I hate Erlang for many reasons, don't get me wrong, and I can spiel. I've got a whole talk about that, actually, about how much I hate Erlang. But this particular topic, Erlang is really useful because it handles all the monitoring and things for you automatically. The tools are all there for you to use, and the patterns are all there for you to use, so that's nice. But you probably can do some of this in .NET if you were so choose, which is nice. I've deliberately kept Erlang out of this slide deck on purpose for that reason. That was a meandering answer. Was it good enough for you? Cool. Any other questions before we wrap up? I can't see any hands. I haven't been blinded by big bright lights here, so I can't really... take a photo of you all, because it's actually quite cool. This is one of the biggest audiences I've ever seen in my entire life. Take a selfie of some sort. Can I see any of you up there? I can. Everyone wave. I was a little bit half-hearted, but I think for a Polish audience that was pretty good. So thank you. Thank you. Talk over.